to our test review. We will go through your homework together and select some of the answers. The very first problem, choose a prime number. As we look through these numbers, I hope that you are going through your divisibility rules and that for 16 you knew right away that 2 goes into the last digit. It's an even number. And since 2 does not go into the 1 for 51, I hope that you immediately added 5 plus 1 and got 6 and knew that 3 does go into 6. And so therefore 6 is divisible by 3, so it's not a prime number. 49, if you look, the 9 is not divisible by 2. 4 plus 9 is not a multiple of 3. Continuing on through your divisibility rules, you would have been stumped unless you tried the number 7. Please make sure that you try the number 7. You have to divide it. Of course, you knew that 49 is a multiple of 7, but sometimes the number is large enough that you do need to try 7. Just divide it and find out. 29 is the only one that has no other factor other than 1 and itself, and 29. So that is our prime number. What are the prime factors of 48? 4 is not a prime number. So A and B are canceled out because of that. And if we go to, let's say C, and we try this out, we know that 2 to the 4th power is going to be 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. And so we take that 16, which is what 2 to the 4th power is, and we multiply it by 3. 16 times 3 is going to be 48, and I believe that's what they were asking for. So since all of these numbers in problem C are prime numbers, prime factors, 3 is a prime number, 2 is a prime number, even though the exponent is a 4. 2 to the 4th power still means 2 times 2 times 2 times 2, and 2 is a prime number. So this is the answer, C, for number 2. Number 3, if I can get some of this out of our way. Number 3, what's the greatest common factor of 16 and 24? Factor being the numbers that we multiply together to get 16 and 24. So that's the fewer the pieces of 16 and 24. So we're going to take 16, 24, and we're going to pull out our factors, our common factors. So I can see right away that 4 goes into both, so I'm going to go ahead and try that. 4 goes into 16 and leaves us with 4 more. 4 goes into 24 and leaves us with 6. And here I notice that I could have gone larger, couldn't I? And so I'm going to pull out a 2. 2 goes into 4 twice. 2 goes into 6 3 times. I'm going to continue on until I get 1. 1 is the largest common factor for 2 and 3. So our answer is 4 times 2, or 8. I'm going to look and make sure 8 does go into 16. 8 does go into 24, and I can't think of a larger number. So voila. We're going to go on to the next one, number 4. What's the LCM of 6, 9, and 3? Listing your multiples. Since we're looking for a multiple, I'm going to list the multiples. I'm going to start with my larger number. Makes my life easy. So I'm going to start with 9, 18, and as I'm writing, I'm thinking, is this a common factor? And I believe I hit one. So let's go ahead and do the factors of 6, 6, 12, 18, and make sure. And the factors of 3 would be 3, 6, 9, 12. Well, there's a common factor for 2 of them, but we need all 3. And then 15, 18. There's our very first common factor for all 3 would be 18 is the least common multiple, the first multiple that 6, 9, and 3 have in common. Good. So we're going to move on to the next one. We have to figure out what did we do when we went from 18 to 72. If I multiply it out, we multiplied by 4. I could multiply 18 times any random number and just pick a number until I get it, or I could, of course, divide 72 divided by 18 to get that number. But it is 4, so we're going to multiply by 4, so 12 times 4 is 48. And we're making equivalent fractions here by filling in the missing component. And then over here we had to decide, how did we go from 28 to 7? Well, that was divide by 4, right? The other direction would be a multiply by 4. And since I'm going to go this direction down here, I need to multiply by 4. 15 times 4 is 60. So number 6 is greater than, less than, or equal to, and I have different denominators. So I'm going to go ahead and make some common denominators, and since I can make both of these denominators equal to 24, I'm going to work over here. I'm going to get this fraction to 5/8 to be, I'm going to make an equivalent fraction for 5/8 so that the denominator is 24ths. So 8 times what is 24? That was a times 3. So I'm going to do times 3 here. 5 times 3 is 15. So now my 5/8 is really 15/24. And so now it's really easy to compare 15/24 and 13/24. That would be this direction. So that means that 5/8 is greater than 13/24. We're going to complete the next statement. Let's see, that's 19/8 is equal to 2 and how many 8s? In other words, we're going to change this improper fraction into a mixed number. We're going to see how many times 8 goes into 19. That was 2. That's why we have the 2 whole numbers. 2 sets of 8 is 16 with 3 left over, so we have 2 and 3 8s. And we're going to mosey on to the next page, and we have a mixed number, and we need to turn it into an improper fraction. So 7 times 5 plus 3, 7 times 5 is 35 sevenths plus 3 sevenths equals 38 sevenths. Got that one? Good. And then write 22/4 as a mixed number in simplest form. Again, we're going to see how many sets of 4 we have in 20. That's going to be 5 with 2 left over. And we need to reduce. So that's going to be, don't forget that whole number, 5 and 1/2. And let's see, now we're going to add some numbers that have different denominators. So we're going to take and make some common denominators out of these numbers. And I can see right now that I would like to have 20 as my common denominator. So how did I go from 5 to 20? That was a times 4. And so the 3 is going to be a times 4, which is a 12. How did I go from 4 to 20? That's times 5. This is times 5, so that's a 15. We're going to add these two fractions together. When I have common denominators, I just bring that denominator over. But 12 plus 15 is going to be 27. This is an improper fraction. I need to see how many sets of 20 are in 27. That's going to be one set with 7 20ths left over. And hopefully you got that one as well. The next one we have is, let's see, boy, this one's going to be fairly easy because we just need to keep 2 and 7/14 the same. So I'm going to put that over here because I'm going to change my first fraction into 14ths. So I can have common denominators. So my 7 times 2 was 14, so 6 times 2 is going to be 12. Now I have my new equation. Always a good idea to write a clean equation rather than writing all over this original one and not being able to see it. Here's my nice clean equation. 5 and 12/14 minus 2 and 7/14. I'm going to subtract the fractions first, and that's going to give me, let's see, 5/14, and then 5 minus 2 is 3. So let's see, problem number 11, put these in order from greatest to least. Now this is going to be one of those that we should write down a little tip to ourselves, G to L, L to G, just so that we remember to check at the end. These again have different denominators, so I'm going to go ahead and change them to a common denominator. I'm going to make 18ths. And let's see, that's going to be times 2, times 2, that's 14, 14 18ths, and then we have times 3, that's 15 18ths, and then I'm going to do times 6, that's 12 18ths. So I'm going to take those fractions and look for the greatest first, and I've got 15 18ths, but that's really 5/6 because they wanted me to put those fractions in order. And then my next largest one is 14 18ths, that's 7/9. And then my last one is going to be 2/3. Now, when I finally get these set in order, let me show you a trick. If you've got them in the correct order, then you can cross multiply and your product should go from greater to least. So watch this. 9 times 5 is 45. And 6 times 7 is 42. Did I go from greater to least, 45 to 42? I sure did. Now I'm going to erase those and do the last two. You only can do 2 at a time when you do these. So now let's look at the next set. Again, 7 times 3 is 21. 9 times 2 is 18. Am I still going greatest to least? Yes, I am. So that proves to me that I do have these in the correct order. I would highly recommend that you do that when you're finished. Great idea on checking your work. So hopefully you got that. I just erased it because it was in my way. You can always backtrack if you missed it. Sorry about that. So then I'm going to look at these and I see that I've got some pretty ugly denominators, and I really don't want to make a huge monster denominator. So I'm going to look at these fractions a little more carefully, and I noticed that, I hope you saw this as well. Did you notice that each of these numerators is 1 less than its denominator? When that happens, we can actually figure this out without making common denominators. So let me give you a background real quick on this. When you have fractions, I think most of you know this, that are 1 away from their denominator. We have 4ths and we have 8s here, don't we? These are 4ths and these are 8s. And let's say I had 3/4, which of course is 1 away from its denominator. And let's say I had 7/8. It's just easier to tell when you have fractions farther away from one another. So which one looks larger? Of course, this one definitely looks larger. So what that tells us is when the numerator is 1 away from the denominator, then the larger the fraction numbers, the larger the fraction. The smaller the numbers, the smaller the piece here. In fact, it's the larger the leftover piece on that one. So, knowing that, let's look at that set real quickly. And if we follow what we just talked about, these are the largest 2 numbers. So that's going to be the largest fraction. This is the next largest. And this is the smallest, and so that's going to be 6/7. And then the very last one, we have 5 as our numerator for each of these. Once again, we can look at that and know that the closer the numerator is to its denominator, the bigger the piece, right? The farther away the numerator is from its denominator, the smaller the piece. If you don't understand that, go ahead and draw a picture of these and it will show it to you. So of course the larger one is going to be the one that's closer to its denominator, which is 5/7. And then we have 5/8, and then we have 5/9. Hopefully you did well. We will see you later, and come on in and ask any questions if you have some. Thanks and have a great day. Bye-bye.